thing. So we are going to do two problems that I'm calling Do You Really Get It? Where I just told the class that we are combining a whole bunch of skills together in two problems before we go work on that review packet. So I might as well show them to you here. So the first one is calculator active. So take out your calculators, but it's not graphed for you. And so I want you to set it up, use your calculator for what you need it for. I'm not going to prompt any more with that. So go ahead on your sheet of paper and you're just going to set up an integral that will result in giving you the area bound by those two functions. It might be one integral, two. I should have put integral with a parentheses. Because it might be one of them, two of them, three of them. You have to decide what you need. So the net result will give you the area. So I'm going to let you do that one first. Those of you at home should do the same thing. And I'll just kind of watch up front when you're, I'm going to give time today for everyone to do it. The intent of this first one is you know how to use your calculator appropriately. I see some people done, so I will scroll to the next one, but if you're not done with this one, you should have it at least written down. The next one is not calculator active. I'll scroll a little bit more. So don't use your calculator to graph any of that. Again, this one should seem hard. I'm trying to tie in about 5 different skills. Notice why it's difficult. I gave you kind of funky functions. We're going perpendicular to the y-axis. We're choosing the most difficult. I call this being really good. There's no graph provided. As hard as it'll get. There are much easier ones, but this one you wouldn't have a calculator for. So those of you on your calculator, I wouldn't use it. Try to think it out. If you don't know what the graph of e to the 2x looks like, you should, because it's one of our parent functions, so it's fair game on no calculator. But if you need to, in your head, plug points in to see what it does. If you're like, well, I don't know what E is, it's about 2.7, so pretend it's 3. I see some of you not ready. Are you ready for a scroll? No? Okay. If you, for those of you done with that one, the second part is revolve around y equals 7. Just setups only on these. So there you go. I saw some of you waiting for me to scroll. So same with those of you at home if you're waiting. The last bullet is find the volume when we revolve the region about y equals 7. Just setups only. And then if you can wave at me when you're done, or, well, when you've done what you can of it is a better way to phrase it. I expect these to be a struggle, that's why I picked them, by the way. Right, Priestley, there's no sense practicing the easy stuff, right? Yeah. There's a method to my madness. Goodness. Got the right region there, that's the first part of the problem. Notice if you can't get the sketch down, you can't really do any of it. I'd say if you ace both of these, you probably don't need to study unless your particle motion and or F's average value needs some looking at. So this is about as bad as the volume area stuff. Yeah. Wave at me when you're done or stuff, whatever. 1, 2, 3, 4, 5. I'm gonna wait till almost out. 6, 7, 8. Still, I want you to be able to think it through fully. So I'm gonna wait till you're 81. Just watch when the pencil stop. That would be a good idea. Put your pencil down. That'd be better. Then I don't have to have you wave at me. When you're done or stuck. Because honestly, if you're still working, you can probably figure it out. It's so quiet in here, and it's a dreary day. All right, I'm gonna start going over it. So, couple things with this first one. That one was calculator active, so definitely graph this on your calculator, graph that on your calculator. Make sure you can see the entire scope of the graphs. All right, so I have those graphed on the next page. This is the first one, the graph of it. Okay, so one thing you have to realize when you're doing the area is there's area in 2 places. So you should have set up 2 integrals. Did you guys catch that? So be careful. This intersection down here is not obvious, so don't guess at it. I don't know what it is though. I just did the graph on Desmos. I didn't calc intersection. So can you tell me what this one was? Somebody who did this real quick. No one's gonna tell me. Yeah, Caden?
-1.414.
Can someone back that? Yes, thank you. Now they're talking. Whenever I record, you guys don't talk to me, but it's okay. They can't hear you. My mic is, I'm using this, so it doesn't pick up your voices. All right, on the top bound, can you give me what the top one was? The intersection up here?
+1.414.
Can I? What's wrong with this? It'll be there. If this is multiple choice, you're going to see that. What's wrong with it? Yeah, the top and the bottom changed. So this needs a 2 integral setup. Okay, so hopefully you caught that. The other intersection was at 0, so we have to have 2 of them. For the first one, top minus, and this said area, so no pies. I'm hoping out front. We're not revolving this one. It was purely area. So we should have done the cubic on top. Was it x cubed plus 2, right? X cubed plus 2 minus the line. What was my linear? 2x plus 2? All right. And it was just the setup. Don't forget the dx. It matters. I take halvesies off for that. And then you'd be going from 0 to 1.414. And then the top and the bottom would switch. Your line is now on top. So you do top function minus in parentheses matter. Bottom function, you don't need to clean it up unless it's multiple choice and you don't see these and you see a simplified version. All right, so if in the multiple choice you're like, well, why is there no constant? Well, the 2's actually do cancel. So be prepared. Did we set that one up correctly? All right, the next one, the issue was knowing what the region was. So it was e to the 2x, which I did here in red. You should know your parent functions. You should know, I know we know x squared and root x and sine x and all those ones that pop up all the time. But also in those are e to the x and natural log of x. So be prepared to work with those and any transformation of them. So all e to the 2x is going to do is be steeper than e to the x. But if you don't have a calculator, just plug in a 0 and say it goes through 0, 1. In your head, plug in a 2 or a 1. E squared would be about 3 squared. It's going to be pretty high up there, so just know it's steep. All right, y equals 1 is this green line right here. And you might say, well, I don't know what ln2 is. It doesn't really matter, right? It's a vertical line, and you can just label it ln2 here so you know. So the region that we're working with is actually this little piece right here. All right, and hopefully you could do that without your calculator. And then I forgot what I asked you to do with it. And I don't want to page back. Was the first bullet was a semicircular build up off the base. All right, so I'm going to start. Was it perpendicular to the x-axis? I think I made it hard. Didn't I? It's perpendicular to the y-axis, right? You guys are my first hour. I think I said perpendicular to the y-axis. So you have to draw your little side length perpendicular to the y-axis. Why would you go, oh, crap. What kind of problem is that? dy. All right? Be careful, because with multiple choice, the dx version is going to be sitting there, and you're going to think you did it right, because you're going to find it. That's what's deadly. All right, so this is a dy problem. It's a pi eighths out front, right? I need to do a side squared, and it's top minus bottom if I had said perpendicular to the x-axis, but this is right minus left. What's the right one? What's the right function? Go ahead and tell me, Luke.
Natural log of 2.
Yes. Natural log of 2 is on the right. X equals natural log of 2. On the left, be careful. It's not e to the 2x. That's the y value there, right? So did you catch that? Again, I made these. That's why I call it, do you really get it? Because you have to know your pre-calc. You have to, I did the semicircle. I went perpendicular to the y-axis. Who caught that? That you needed to solve this for x. What did you get when you solved it for x then?
Natural log of y over 2.
Mm-hmm. That's pre-calc right there. It's fair game in calculus, right? So this is natural log of y over 2 would be your x value there. So you're going to do right minus left, which would be ln y over 2 dy. What's wrong with mine? There's no limits. What else is wrong with mine? I'm purposely doing this to make you think.
squared.
It needs to be squared. Yep, the integrand on pretty much all of them, unless it says rectangles and those have a constant height, there's an s squared in all of those cross sections. All right, so I need to square it. All right. What's wrong with mine? I now have limits. And you might say that is 0 to ln2. I said, yep, across the x-axis, but I'm going up the y-axis. Did we catch that? So my y's are going from 1 up to not ln2. What are my y's going from 1 up to? E to the what? ln4. What's wrong with that? Technically, I'd have to mark that right, but really, what is it? You won't see that if it's multiple choice. What, 4? Yes, E and natural log undo each other. If you got that, you got it. It had everything in it. All right? Anyone get that one right? Just 1, 2, 3. Okay. So, well, I wasn't expecting many. That's why I picked it. All right. The other thing I asked you to do was revolve it. Right? Keep in mind, if you didn't get the sketch, how you wouldn't get it. That'd be like, if it's multiple choice, that's 1 off. It's not a big deal, but you have to be able to sketch without a calculator. So what did I tell you to revolve it around? I don't remember, to be honest.
Y equals 7.
Y, thank you, hon. Y equals 7 is up here. I like that. Because those horizontal ones, at least I can go dx, right? So when I revolve it, pi times across the x-axis, right? We always go perpendicular to the axis of rotation. So now I'm going like this, right? And I really have a lot of dental floss here connecting. So this is a washer, right? It's going to revolve way up and around. But the process doesn't change. Okay? We do big R squared. Top function, 7, minus bottom function. Big R is the same regardless of where you drew your rectangle in there. What's big R? 6. I heard somebody whisper it. Yes. What's wrong with it?
Squared.
I didn't square it. That will be, if it's multiple choice, you're going to see just a 6 there. All right, so be careful. You have to have all your ducks in a row. Big R squared minus little r. Top. I wonder if I'm going to do little r here. And we have time today, so I don't feel bad. This is very helpful, by the way. Some people asked if I was doing an after-school session. This is it. So, yes, but this is it. So little r is axis to the inner edge of the curve, or the top of your representative rectangle. Top minus bottom. What's bottom? What's the bottom? E to the 2x. What's wrong with it? I didn't square it. Okay. Another thing that you'll see if it's multiple choice is, and again, this next test is very AP focused. So it's AP multiple choice, AP FRQs. And one thing that they'll do is have that it's not like multiple choice that you're used to in math. I think you're getting used to that in that they spend a lot of time doing the distractors. There's people, that's their job. Like, what other answer should we put there? Well, a lot of kids are going to forget to square it, so they put that one there. A lot of kids will do big R minus little r quantitatively squared. So they'll put that one there. When it's dy, kids are going to forget and go across the x-axis, so they'll put that one there. They're all reasonable answers, and that's deadly. So that's why I'm spending so much time on this. This one's now done. Okay. Keep in mind, if you didn't find it, maybe you see a 36. Maybe that got foiled, but I doubt it. But just, if you're not finding your answer, it doesn't necessarily mean it's wrong. You might need to clean house a little bit. All right. The rest of the hour, you get to work on that review packet. For 40 minutes, is it? Half hour. Get as far as you can get. I'd really focus maybe on the FRQs in class, because I think you'll have more questions about those. The scoring guidelines before I stop, those of you at home, I didn't attach on the key the scoring for the FRQs in the review packet, but I put a link on, I think, both yesterday's slide and today's slide that'll take you to where all of them are. So you just have to find the year and the problem number. What was that? All right. Calculus or TikToks? I think calculus today. Yeah, or both. Or calculus.